Forget frequently asked questions.
Common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
go above and beyond.
They become very good at what they do, but only
0.1%
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
with Richard Jacobs.
Before we begin, a note from our sponsor. I'm Richard Jacobs, Executive Director of the nonprofit Finding Genius Foundation and host of the Finding Genius Podcast. In late 2016, I was rear-ended at 65 miles an hour by a truck on the highway, which sent me off-road into a ditch. The impact of the collision gave me a concussion and other injuries. At the hospital, a CT scan showed that I had thyroid nodules, which turned out to be cancer. It was then, when I had a biopsy of my neck, that I realized even if I was a millionaire, I wouldn't want a second or a third biopsy due to the pain and the invasiveness of it. And appointments at that time for thyroid experts were 3 to 6 months out. And I was worried about dying now, even if that was irrational. So because of this, I've decided to raise money to conduct a literature review on steroids, on the causes of anxiety and depression, a condition that affects well over 50 million people in the United States and hundreds of millions worldwide. Our goal is to create a codex, a guide that reveals all possible treatments for anxiety and depression for people that live with the condition, or for loved ones that have it, as my wife and my son do. To find out more about our fundraiser, visit findinggeniusfoundation.org and click on current initiatives. And now, to our guest.
Hello, this is Richard Jacobs with the Finding Genius Podcast, now part of the Finding Genius Foundation. I have Luisa Diele-Viegas. She's a postdoctoral researcher at the Federal University of Alagoas in Maceió, Brazil. I hope I haven't ruined the pronunciation of that. We're going to talk about her work in climate change and organismal biology. So, Luisa, thank you for coming.
You're welcome. It's a really pleasure for me to be here.
Good. Tell me about your work. What's the main focus of it?
So I basically evaluate how our actions impact the biodiversity. So basically, I'm focused on how climate change and other issues such as the agriculture and the fires, intentional fires, impacts the biodiversity, the terrestrial biodiversity. By focus on reptiles and amphibians, I can evaluate such impacts by understanding their physiology and their relationship with the environment.
Well, what organisms do you study and where are they? All over the world or in Brazil only or where?
I mainly focus on lizards and snakes and also frogs. I basically focus on the animals from the Amazon and other Brazilian biomes, but I'm also work in a macroecological way. In this sense, I also try to understand the overall patterns of such impacts. And in that case, I also study individuals from all over the world.
What are you studying in particular? What animals and how are they affected? Do you have any examples so far?
Considering lizards, they are basically affected by the increase of temperature, of the environmental temperature in their habitats. So when the temperature increases, they usually try to find better place to live, and for that they need to move. Not all species are able to move to better environments, so I discovered that some species in the Amazon rainforest, for example, they are trying to cope with these changes, these environmental changes, by developing some behaviors, such as finding a refuge or something like that, like a thermal refugia. So they can just hide during the high temperatures, during the daily variation in temperature. But when they do that, they just lost the ability to thermoregulate and to find resources so they can eat and they can reproduce. With the climate change, we have an increase in temperature, so these animals need to stay longer in these refugia places, and they cannot just find food and search for a partner to reproduce. And so in a medium term, most of these species will likely to lose their ability to cope with the climate change.
Well, what do you mean? How much is the temperature variation daily, and how much is it now? If you compare, I'm not sure when you're comparing to, but how much has the temperature gone up or increased or changed the variation in a given day on average?
Yeah, currently we don't have a greater variation in temperature, like daily variation, because in the tropical environment, we have like a stable temperature all over the day. It's a high temperature, usually around 32 degrees Celsius, 28 degrees Celsius, but we don't have a great variation during the day. But we think with the climate change, with the increase of temperature that we are already experiencing, such temperature is reaching really high heights of temperature. So we have like an environment that is usually around 28 degrees Celsius all over the year. This is the average. Currently, we are reaching like 40 degrees Celsius in most of the summer. So this is really high temperature for such animals, even considering that they are adapted to high temperatures because they are in tropical environments. The temperatures that they are experiencing now, it's over their ability to cope with it. So when basically it's like the animals are used to temperatures around 28, 30 degrees Celsius, and now they are experiencing temperatures above 35, 38 degrees Celsius.
So how many days a year are they experiencing temperatures above 35, 36? And when did this happen? How soon has this phenomenon started happening? What does the data say?
So basically, we are having that in the last couple of years. Mainly in the last 5 years, we had an increase in the temperature and a decrease in the pluviosity, in the precipitation patterns. So the environment is becoming hotter and drier in the Amazon forest and other biomes as well. So in Pantanal wetlands, which is also in Brazil, we are experiencing the worst dry season of the last 50 years. We had that on September 2020. And that was the period where we have the increase of the fires in the Pantanal wetlands as well. So this increase of fires also increase local temperature and decrease the relative humidity, that environment. This is also happening in the Amazon. We are experiencing this increase of temperature in the last few years and also the decrease in the precipitation patterns. And it's like what we call like savanization of the Amazon is basically the environment becoming hotter and drier every year. So if we consider that we are talking about a wet environment, both Pantanal and the Amazon rainforest are pretty wet because the Amazon rainforest is a rainforest, so it's always raining. We have a really high pattern of precipitation all over the year. And in the last few years, this pattern is decreasing. So the forecast for the future for like 10 years from now or 20 years from now is that this pattern will become even stronger. So we will probably face an increase of about 5 degrees Celsius compared to before the climate change started, so before the industrial period. And this 5 degrees increase in the temperature is likely to impact not only the lizards that I study, but also other organisms as well.
Do you assume that the pattern is going to continue? Like which models are you using to see what's going to happen from here, temperature-wise and humidity-wise?
So we have like really high deforestation levels in the Amazon and other biomes in Brazil for now. We have an increase in these deforestation levels in the last 3 years. And together with this pattern of deforestation, we also have observed changes in temperature and precipitation. For the future, we consider the different scenarios of greenhouse gases emissions that are scenarios the same scenarios that the Intergovernmental Panel of Climate Change use to forecast the impacts of climate change all around the world. And these different scenarios in the Amazon, they also consider issues like political issues and socioeconomic issues, such as the use of protected areas, as the actual effectiveness of the protected areas in Brazil. Currently, we have these protected areas are not that effective because we have a lot of issues with how the government actually take care of it. So far, we have a lot of protected areas in the Amazon, but we also have a lot of illegal activities inside these protected areas. So such issues are also considered in these future scenarios of climate change. When we predict the occurrence or the extinction risk of different species, we also consider such issues like governmental issues and socioeconomic issues in our forecasts.
Before we continue, I've been personally funding the Finding Genius podcast for 4.5 years now, which has led to 2,700 plus interviews of clinicians, researchers, scientists, CEOs, and other amazing people who are working to advance science and improve our lives and our world. Even though this podcast gets 100,000 plus downloads a month, we need your help to reach hundreds of thousands more worldwide. Please visit findinggeniuspodcast.com and click on Support Us. We have 3 levels of membership from $10 to $49 a month, including perks such as the ability to see ahead in our interview calendar and ask questions of upcoming guests, transcripts of podcasts you're interested in, the ability to request specific topics or guests, and more. Visit findinggeniuspodcast.com and click Support Us today. Now, back to the show.
What are temperature refuges? You mentioned that earlier. Like during the day and the night, where can lizards go to, stay away from the heat of the day?
They usually find like holes or falling trunks, so they can just hide there. Depending on the species, they also try to find these holes on trees, but it depends on the species. It depends on the group that we are talking about. We have a lot of fossorial individuals that actually live inside the floor. So these animals are more likely to suffer with the climate change because they already live in refugia, if you consider their way of living, so their habitats. But usually they find some holes in falling trunks or something like that, so they just can hide far away from the sun, usually, because it's too hot when we have the sun.
So have you observed that lizards are hiding out more of the day or sometimes all day when it's hot? Like, what is the change in their behaviors and what's the consequence?
Yeah, actually, one of the species I study is an island species from the coast of Brazil. It's an island called Fernando de Noronha. In this island, we have this species called Trachylepis atlantica. This species only occurs in this island, is endemic from this island. And because it's island endemic, really sensitive species, because if anything changes in the island, the species cannot just move to another place because it's really far from the coast. In this case, this species, it's a lizard that is used to be in the sun. So it call it heliotherm because it's a species that likes to be in the sun. It gets his optimal temperature by staying outside, staying in the sun. And in the last 10 years, we have been observing that this species is getting more and more in these refugia in the island. So they usually around 11 a.m., it reach like these holes in the wall or some rocks or something like that. You just hide and they stay there until around 2 p.m. So between 11 a.m. and 2 p.m., the individuals are usually hiding from the sun. But the issue is that these species start its activity around 8 a.m. and it ends up around 4 p.m. So when we consider that between 8 a.m. and 4 p.m., these species cannot be active between 11 and 2 p.m., we have most of the time it was supposed to be active, it is actually hiding from the hot environment. So this is a species that is really, it's considered endangered because of the climate change. It's one of the studies that I am working on, and our forecast is that these species can be extinct by 2070 if it cannot cope with this thermal variation that we found in the island.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
Well, is it eating less? Like what do they eat? And how do you know that they're being negatively affected? What have you observed?
Yeah, when the animal goes to these refugia sites, it cannot search for food. So it's a place where they just stay there and wait until the environmental temperature is better for them. So when it does that, it cannot search for food. And if, let's say that they had lunch before go to the refugia, when they stay in these places, they cannot reach their optimal temperature, optimal body temperature to actually to keep their metabolism active and to perform their body. Even if they eat before they go to the refugia, they don't have enough energy to digest the food. So they just stay with the food in their belly, and then when the temperature outside is better, they will go outside and then thermoregulate so they can reach the optimal temperature they need to digest their food. These animals are ectotherms, so they depends on the environmental temperature to regulate their body temperature and then keep their metabolism active. So any changes in the environmental temperature will change their body temperature, and then it impacts their whole fitness, their whole life.
Well, so the lizards changing the hours in which they forage? Are they eating less? What do they eat? And what have you directly observed that has changed with them versus what's been modeled?
Sorry, I didn't understand.
Do the lizards eat less? Or do they expand the hours in which they hunt? Has anyone observationally watched them to see if they run around longer? Maybe now because they're staying away longer in the day, do they stay out later? Do they eat different things? Are they eating less? What have you observed directly that's different?
Yeah, so far what we are seeing is that they are eating less. Of course, some species can just change their activity period. But to do that is not individual choice. It is a characteristic of the species. So if they are plastic about their activity period, so just then they can change the start and the end of their activity period. But usually they don't have this plasticity, or if they don't have, they need to develop it, and they need to do that over generations. It's like the evolution. It's how the evolution works. And it's also like this process of adaptation to new environmental condition works. So they need time over generations so they can adapt to this new condition. So far, what they are basically doing is finding a refugia and then stop eating during that period. And when the environmental temperature is okay for them to go out, they use the rest of their activity period so they can actually find food and reproduce. While they are in the refugia, they are not able to do so. And when they go out, they have less time to do what they need to do until the end of their activity period, which is for this species specifically is around 4 p.m. 4:30 is not exactly, but around 4 p.m. There are some other species that has longer activity periods, and for those species, they still have more time to go out, even with the restriction in their activity because of climate change. But it depends on the species, and it depends on their plasticity to change such activity period because of their biology.
But what do these lizards eat Have you noticed that the things they eat now are in greater abundance because they're not eating as many of them? Like, what are the other effects you've seen?
They eat mostly insects. There are some lizards that are herbivorous, so they just eat plants and fruits. But most of the lizards eat insects or arthropods like spiders or something like that. And in that case, considering the island species that I mentioned, it eats mostly insects and arachnids, and they usually find these animals during the day. So the animals that they eat are usually out during the day. And this is another issue. So insects are also ectotherms, and they are also impacted by climate change. So lizards and other species like amphibians, all these animals are also indirectly affected by climate change because their food is being affected as well. So insects
if lizards are eating less insects, I would think that you would see more insects. The populations of them would increase. So has anyone looked to see if the density or population of insects has increased because they're not being eaten as much by the lizards? Or are they being eaten by something else? Or what do you think is happening?
That's a possibility, yes, for sure. But there is also the possibility that these insects are also being affected by climate change because they are also ectotherms. The issue is that this line of research in Brazil is still very incipient. We have a lot of species that were not studied yet, considering climate change impacts. So for insects, I believe there are some studies, but it's not like we know everything that is going on with our biodiversity. We are still getting there. For amphibians and reptiles as well, we don't have enough data to talk about all lizards and all amphibians and all snakes and all biodiversity that we have in Brazil. And Brazil is the most biodiverse country in the world. It's another issue. We lack data on most of the species, we don't know the impacts of climate change and these indirect impacts of climate change, such as that one that I just mentioned, which is the impacts on the food. We don't know that for most of the species. So we are trying to run against time to get this data, to understand what is going on, and to actually do something to avoid a biodiversity collapse.
Well, what eats the lizards? What larger creatures eat them? And what has happened to their population? Have you looked that way too?
Yeah, we have birds, we have snakes, we have some mammals that eat such lizards, and even some spiders also eat some lizards, depending on the size of the lizard. And as well, we have some work on the birds, for example. Most of the work we have on climate change impacts on birds are focused on migratory species, how climate change impacts their migration patterns, which also impacts their reproduction. We also have, regarding snakes, within my line of research, we still have very few works with climate change and snakes in Brazil, mostly focused on their distribution. So focus on how the species will respond to climate change by expanding or decreasing their distribution area. But we are still lacking data on the impacts of climate change on their physiology and their ecology and their evolutionary process. So these studies are being developed, are starting to be developed. We don't have enough data to most of the species.
Where can people find out more about your research? What are some good places for them to go?
So I have a website I can share with you. I have actually a scientific communication channel on Instagram and on TikTok as well, where I talk about my research and other curiosities about this field of research. And yeah, basically I use these tools so I can share a little bit about my knowledge on these animals and other scientific issues as well.
That's great. So people should search on social media for what? Luisa
Diele-Viegas LM. It's my last name and then my initials.
Okay, got it. Well, Luisa, thank you for coming on the podcast. I appreciate it.
Thank you. It was my pleasure to be here, and it was really nice to talk to you.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.